For the last topic of this class, I want to talk about sequences and series. So first, let's talk about arithmetic sequences. Arithmetic sequences is, first of all, sequence is just a setup number. It's more like a function, but the domain is just real numbers, integers. So what you have right here is an equals to 49 plus 7n minus 1. And then they want you to find the first four terms. So it's straightforward. All you have to do is do one by one. So a1 is going to be 49 plus 7, and then n is going to be 1. And then from there, you just solve it. So what I have for this first one is 49. And then a2 is going to be 49 plus 7, 2 minus 1. So you're just replacing the number. So n is 2, so n is 2. And then so on. So we have 49 plus 7 is 56. And then we have A3 is going to be 49 plus 7 to, 3 minus 1. And so on. So it's going to be 63 here. And then the fourth one is going to be 4 minus 1. And you can see that if we simply adding 7 to the number, you should get the result. So we have 49 to 56. I add 7. I add 7. If I keep adding 7, I'm going to get the next term. Okay, so number 13, what you have right here is not arithmetic, but it's geometric. Okay, so same thing, A1 is going to be 4, and then we have 3, 1 minus 1. So the first term you can see is 4. A2, 4 times 3, 2 minus 1, so it's 12. A3, 4, 3, and then we have 3 minus 1 is 36. A4, and if you see the pattern, you can tell that if we take the number, we multiply by 3, you're going to get the next term. So 4 times 3, you get 12. Times 3, you get 36. Times 3, you're going to get 108. Right? So that's what sequence is all about. So we have a specific order. Moving on to number 14. All right, so this one right here, we're gonna do the exact same thing, but this time you see that we have fractions, so make sure you be careful with that. So A1 is gonna be 3 to the first power plus 2 over 3 to the first power, which is 5/3. A2 11/9. A3 3 cubed plus 2 over 3 cubed is 29 over 27. A4 is 3 to the fourth plus 2 over 3 to the fourth is 83 over 81. Okay, now you see that for number 15 they don't give you the rule, but you know that is arithmetic, so we're gonna have a common difference. D is called a common difference, which means you adding the same number to get the next term. So you see that from negative 22 if you add 7, you're going to get negative 15. Negative 15, if you add 7, you're going to get negative 8. So if you take negative 8, you add 7, you're going to get negative 1. You take negative 1, you add 7, you're going to get 6. So these are the terms of the sequence. And if you keep adding 7, you're going to get the next term, the following term. All right, so you see right here we have this sequence. Um, uh, Really, you're gonna have to do it one by one. So you're gonna have to go in order because what they have, an is defined by an minus 1. Okay, so we have to do it one by one. So a1, so I'm gonna do a2. So a2 is gonna be 4. A1 because it's 2 minus 1 plus 5. So we have 4. A1 is given, which is negative 2 plus 5. So it's, negative 8 plus 5. Negative 3. And then A3 is going to be 4. A2 plus 5. So it's 4. A2 is negative 3 plus 5. So it's negative 12 plus 5. It's negative 7. A4 is going to be 4 times A3 plus 5. So we have 4 times negative 7 plus 5. So it's going to be negative 23. Okay. All right, so you notice that for arithmetic, we have the common difference, so we keep adding the same number, right? So for the next questions, they just want you to write down whether we have the arithmetic or not arithmetic. So you see right here, we have from negative 2, we get negative 8. So if I subtract negative 6. So in a way, adding negative 6, I'm going to get negative 8. So let's try adding negative 6. I'm going to get negative 14. Adding negative 6, I'm going to get negative 20. So this is in fact an arithmetic, and D is going to be negative 6. Okay. Now, how do we get from 4 to 8, 8 to 16? You see that we multiply. We multiply by 2, by 2, by 2. So this is not arithmetic. Arithmetic, we have to add, not multiply. From negative 1 to 6, if I add 7, I'm going to get negative 1 plus 7 is 6. 6 plus 7 is 13. 13 plus 7 is 20. So in fact, this is arithmetic. And D is going to be 7. Moving on to number 16. So number 16, they give you a sequence and they're asking you for a specific terms. They're asking you for 60th. So I'm asking for a 60. Now, I have the formula right there for you. This is the general formula. So you see A1. In this case, the first term is 17 plus 60 minus 1 because n is 60. Now the common ratio, the common difference, you have to figure it out. So from 17 to 25, we're adding 8. And then if we add 8, you're going to get 33. If you add 8, you're going to get 41. Therefore, D is going to be 8. And then from there, you just use your calculator to get the answer. 59 times 8. So I just want to make sure I get everything correct. Times 8. So I should get 489 for the 60th term. Moving on to number 19. So for this one, they give you the first term, they give you D. So you just have to plug it in. So 814 is going to be A1 plus 14 minus 1. I'm using the formula earlier, times D, and D in this case is 6. A1 is 3. So that's all you have to do. You use the formula. So you can see that right here we have 81 for our answer. Okay. All right, moving on to number 20. Number 20, they're asking you for the sum, so which is a series. So for the sum, you need the formula, and I give you the formula right there. So what do we need for the formula? First of all, you need the number of the number of terms, which is n. You need the first term and you need the last term. So you see for part A, I do have the first term, which is 8. The last term is negative 497. What I don't have is the number of the series, is the number of terms. So how do I figure it out? I can use the original formula for an and figure it out. So we have an, we have a1. We're looking for n here, right? And we have d. You can figure out d. So let's plug it in. An is negative 497. A1 is 8. I don't know n. And then d. You see from a 8 to 3, I'm adding negative 5. And then from 3 to negative 2, I'm adding negative 5. So D is negative 5. And then from here, you just calculate the number to solve for n. So what I have right here, if I distribute negative 5, I get negative 5n plus 5. And then from here, I'm just going to go ahead and calculate for n. So I got 13 here minus 5n. So n is 102. Now we have everything, so I have S102 equals to 102. A1 is 8 minus 497 because that's A102 over 2. And then I have to use a calculator one more time. So 8 minus 497 times 102 divided by 2. So the answer should be negative 24,939. And that's how you find part A. For part B, you see that we have n. This is the number of n, which is 100. We don't have a1 and an, but you can use the formula right here to get an and a1. So a1 is going to be 2 times 1 plus 4. So that's 6. an. In this case, I'm going to use a100. It's going to be 2 times 100 plus 4, which is 204. So from here, once again, I'm going to use the formula. So I have 100 term. The first one is 6. The last one is 204. Divide by 2. And the answer is 10,500. For number 21, what we're looking at is the geometric sequence. So unlike arithmetic, this one we have a common ratio. So the common ratio is the number that you multiply by the first term to get the second term. So you see that in this case, from 2 to negative 8, I multiply by negative 4. And then negative 8 multiply negative 4, I'm going to get 32. So keep doing this in this manner. I'm going to get the next term. So 32 multiplied by negative 4 is going to be negative 128. And then negative 128, I multiply by negative 4, I'm going to get back to a positive, and it's 512. Okay, so that's how you find geometric. So, same thing. This one, how do we figure out whether it's we have arithmetic, geometric, or neither? So you see 2000, and then we have from 2000 to 200 to 20 to 2. So what you see is if we keep multiplying by 1/10, we're going to get the next term, right? So this one is geometric. For the next sequence, we have 14, 16, 18, 20. So if I'm keep adding 2, I'm going to get the answer. So this one should be arithmetic because D is going to be 2. I'm keep adding the same number. Now 25 for the next sequence. From 25, if I multiply by 1/5, I'm gonna get 5. Multiply by 1/5, I'm gonna get 1. But if I multiply by 1/5 one more time, I'm not gonna get 5. So I should get 1/5 instead of 5. So this one is neither. All right, moving on to this one right here. So they want you to determine whether we have geometric or not. So for geometric, we need the common ratio. Negative 5 to negative 10, we multiply by 2, multiply by 2, multiply by 2. We got it. So this one, in fact, is a geometric, and R should be 2. 250. If you multiply by 1/5, you're going to get 50. 1/5, you're going to get 10. 1/5, you're going to get 2. So this one has a common ratio as 1/5. For 16, 16 to 12, I can't really multiply any number to get to 12, and then same number to get to 8, same number to get to 4. So this one is not geometric. Okay. All right, now what we want to do is we want to find the 13. So I have the formula right here for you. AN equals to A1, R to the N minus 1. I can just rewrite. Equals to A1, R to the N minus 1. So to find the next term, I just have to do exactly like I did before. So plug it in, the number. So I have A1 is 4. R. So what is R in this case? If you see I multiply by 3, I'm going to get the next term. So R should be 3. And we have 13 minus 1. So that's 12. So using the calculator, so what I have, make sure you take care of the exponents first. So I'm going to take care of the exponents. I'm going to have, since I'm using graphing calculator, technically I don't have any problems with the exponents. But if you use scientific and you can't see the number, make sure you take care of the exponents first. Okay, so it's a big number, 2,125,764. All right, for number 25, we want to find the 8th term of geometric whose common ratio. So once again, I have a 8, and then the first term is 2, common ratio is 2/3, n minus 1, so that's 7. Okay. This one, I kind of don't want to use a calculator for this one, so I'm just gonna go ahead and simplify. So what is 2 to the 7th is 128 over 3 to the 7th is 2187. Okay, I can't really simplify the 2, so I'm just going to multiply 2 times 128 for the numerator, which is 256 over 2187. Okay. All right, now moving on to this is what we have for infinite. So for infinite sum, that's going to be the formula for you right there. Now, what do you have? The most important of infinite sum is you have to check for r. You see, in this case, r is -5. If I take -5, I take the absolute values of -5, I'm going to get 5. And 5 is greater than 1. So we don't have the sum for the first one. Very important. You can't do it. Okay, so r has to be smaller than 1. Now, for the next one, we do have r smaller than, than 1. So if I take the absolute values of 3/5 is smaller than 1. Okay, so I can use the formula. A1 is going to be -3/5. 1 minus -3/5, so that's 1 over 3/5. This one right here, I'm just going to use the LCD. I'm sorry, I'm just going to simplify. I don't need the LCD. I need the LCD for the bottom. So you see 5 plus 3 is 8 over 5. So when you divide, you're going to get -3 over 8. I don't need a calculator for this.